What if the biggest story in clean transportation isn't electric cars, but the invisible hydrogen economy quietly being built behind them? While the world argues about Tesla, charging stations, and battery range, some of the largest industrial companies on Earth are pouring billions into something most people believe already failed: hydrogen fuel cells. Toyota, BMW, Volvo, Daimler, Hyundai, Air Liquide, Linde, Shell. These are not small speculative startups making desperate bets. These are companies that understand infrastructure, supply chains, energy systems, and industrial survival. And despite years of headlines claiming hydrogen is dead, they keep investing anyway. Which raises a dangerous question. What if the public completely misunderstood where hydrogen was actually supposed to win? Because the truth is, hydrogen was never really about replacing every gasoline car on Earth. That was the distraction. The real hydrogen economy was always hiding somewhere much larger, much heavier, and far more difficult to electrify. Behind ports, steel plants, fertilizer systems, data centers, heavy trucks, industrial heat, backup power, logistics corridors. And now, suddenly, the world's energy systems are beginning to collide in ways that make hydrogen relevant again. At first glance, the hydrogen story looks like a failure. Hydrogen cars never became mainstream. Fueling stations remained scarce. Projects were delayed, costs stayed high, battery electric vehicles dominated headlines, investors lost patience, governments shifted narratives. Critics called hydrogen inefficient, expensive, and unrealistic. And in some areas, they were right. Hydrogen lost the passenger vehicle war years ago. But here's the problem with that conclusion. Civilization is not powered by passenger sedans. Civilization is powered by industrial systems. And industrial systems operate under completely different physics, economics, and constraints than consumer vehicles. This is the part almost nobody talks about. A battery works extremely well when you need short-range transportation with relatively predictable charging cycles. But once you move into long-haul freight, 24-hour industrial operations, maritime transport, aviation, mining, rail, fertilizer production, and grid stabilization, the equation changes dramatically. Suddenly, energy density matters more. Downtime becomes catastrophic. Payload losses become expensive. Charging infrastructure becomes enormous. Utilization becomes everything. Imagine a heavy-duty truck moving freight across North America nearly non-stop. If that truck sits for hours charging, the economics collapse. The vehicle itself is only part of the system. The real business model depends on logistics flow, delivery timing, warehouse coordination, labor schedules, and asset utilization. In logistics, idle equipment is death. This is why companies like Daimler and Volvo created cell-centric. Not because hydrogen passenger cars succeeded, but because they believe hydrogen fuel cells may still dominate sectors where batteries create operational bottlenecks. And this is where the hidden hydrogen economy begins. Because hydrogen's biggest advantage is not necessarily efficiency. In fact, batteries are often more energy efficient from source to wheel. Hydrogen's advantage is system flexibility under stress. That distinction changes everything. When Toyota continues investing in hydrogen despite years of criticism, they are not simply betting on cars anymore. They are betting on a future energy architecture where electricity alone may struggle to carry civilization's growing industrial burden. Now layer in AI. Suddenly, global electricity demand forecasts are exploding. Data centers are becoming energy monsters. AI infrastructure requires enormous amounts of continuous power. Utilities are warning about grid stress. Transmission bottlenecks are worsening. Natural gas demand is climbing again. And now companies are searching for backup energy systems capable of stabilizing increasingly fragile electrical infrastructure. This is where hydrogen fuel cells quietly re-enter the conversation. Because fuel cells are not just transportation technology, they are energy conversion systems. They can provide distributed power, backup power, remote power, industrial resilience, and long-duration operational stability. Bloom Energy, Fuel Cell Energy, Plug Power, and others increasingly position themselves not only as hydrogen companies, but as infrastructure resilience companies. And resilience is becoming one of the most valuable commodities of the 21st century. But then we hit the real problem. The technology works, the system doesn't. This is the hidden reality inside almost every hydrogen project on Earth. Electrolyzers can produce hydrogen, fuel cells can generate electricity. hydrogen trucks can operate successfully. Hydrogen steel production is technically possible. Green ammonia works, the chemistry is real, the engineering is real, the thermodynamics are understood. But the surrounding system is incredibly difficult. And this is where most public conversations completely fail. People think the hydrogen challenge is primarily about inventing better technology. In reality, the biggest barriers are utilization, infrastructure, financing, logistics, permitting, grid interconnection, water systems, storage, compression, transportation, and long-term offtake agreements. For example, a green hydrogen plant can look profitable on paper at high utilization rates. But if renewable power variability causes low operating hours, the economics can collapse almost instantly. A project modeled at 90% utilization may completely fail at 40%. Suddenly, hydrogen costs per kilogram explode upward. Financing becomes difficult. Investors panic. Developers delay final investment decisions, and billion-dollar announcements quietly disappear. This is why so many hydrogen projects stall before FI. Not because hydrogen molecules stopped working, but because industrial systems are brutally unforgiving. And this is where the world may be entering a dangerous misunderstanding phase. Many people see hydrogen project cancellations and assume the entire hydrogen economy is collapsing. But what may actually be happening is something much more important. The market is separating fantasy hydrogen from survivable hydrogen. That distinction matters enormously, because the first generation of hydrogen hype often assumed hydrogen would rapidly replace everything. Cars, homes, heating, entire grids, massive exports, immediate scale. But real industrial systems move slower. Infrastructure evolves in layers. Capital deployment follows survivability, not excitement. Now the industry is entering a harder phase, the execution phase. And execution is where most energy revolutions become brutally selective. Who can survive low utilization? Who has cheap power access? Who controls industrial demand? Who has infrastructure advantages? Who can secure long-term contracts? Who can integrate hydrogen into existing industrial systems instead of building entirely new ecosystems from scratch? This is why companies like Linde and Air Liquide matter so much. Because they already operate parts of the invisible industrial hydrogen economy most people never see. Hydrogen is already used globally in refining, ammonia production, chemicals, metallurgy, electronics, and industrial processing. The future hydrogen economy is not emerging from nothing. It is evolving from an existing industrial backbone. And that backbone may become strategically critical as decarbonization pressures intensify. Now consider steel. Steel production alone represents one of the largest industrial emission sources on Earth. Traditional blast furnaces depend heavily on coal. Green hydrogen offers a pathway to direct reduced iron production with lower carbon emissions. Europe, particularly Germany and Scandinavia, is aggressively pursuing this transition. But once again, the issue is not whether the chemistry works. The issue is whether entire industrial systems can economically survive the transition. And this is where the global energy competition becomes fascinating. Because countries are no longer simply competing on technology. They are competing on system survivability. Who has cheap renewable energy? Who has port infrastructure? Who has water access? Who has transmission capacity? Who can produce green ammonia cheapest? Who can attract industrial clusters? Who can survive subsidy reductions? The future winners may not necessarily be the countries with the best hydrogen technology. They may be the countries with the strongest overall systems. And suddenly, hydrogen stops looking like a simple energy story. It becomes a civilization infrastructure story. Nowhere is this more obvious than in shipping and fertilizer. Global shipping cannot easily electrify using batteries alone for long-distance ocean transport. Meanwhile, ammonia, which can be produced using hydrogen, is already deeply integrated into global agriculture. Fertilizer systems literally support billions of human lives. And now green ammonia sits at the intersection of food systems, energy systems, industrial decarbonization, and geopolitics. This is why hydrogen may ultimately matter far more for civilization than for consumer transportation. Because civilization runs on molecules as much as electrons. And electrons alone may not solve everything. Especially once you include seasonal storage, industrial feedstocks, maritime transport, aviation fuels, backup resilience, and geopolitical energy security. But we also need to be honest about the dangers. hydrogen is not magically guaranteed to succeed. Many projects will fail. Some companies will collapse. Some infrastructure plans are unrealistic. Some hydrogen pathways will remain permanently uneconomic. Some governments may reduce subsidies before industries mature. And some regions simply lack the energy economics necessary to compete. This is why the hydrogen industry is entering its most important phase yet. Not the hype phase, the survival phase. And survival phases create real winners. Because once weak projects disappear, stronger systems begin to emerge underneath the noise. This is why Toyota, BMW, Volvo, Hyundai, Daimler, Shell, and major industrial gas companies continue investing despite public skepticism. They may see something the broader market still misunderstands, not a universal hydrogen future, but a strategic hydrogen layer embedded inside the future industrial economy. An invisible hydrogen economy, quietly forming behind ports, pipelines, fertilizer plants, data centers, industrial clusters, heavy trucking corridors, and backup energy systems, while the public focuses almost entirely on passenger EVs. And if that hidden system succeeds, it could reshape global industry over the next 20 years without most people realizing it until the infrastructure is already built. But if it fails, the consequences are enormous. Because many decarbonization roadmaps now partially depend on hydrogen solving problems batteries struggle to solve alone. Which means the future may not be battery versus hydrogen at all. That may have been the wrong question from the beginning. The real question may be this: what combination of electrons, molecules, infrastructure, and industrial systems can actually survive the stress of powering civilization at scale? And right now, the world is racing to find out. If you want deeper system-level analysis on green hydrogen, industrial decarbonization, fuel cells, project economics, and the hidden infrastructure shaping the future energy economy, explore H2 Hub by ReneEnergy using the link in the description below. And if you think hydrogen is either completely dead or guaranteed to dominate everything, you may already be missing the real story.